Guys, I'm not going to spend a ton of time in this section. I know you guys have talked about this before. We're going to talk about some different theorems that come along with this. But guys, how many have heard of the Pythagorean Theorem? When you think Pythagorean Theorem, what do you know about? What have you heard? What do you remember? Say it again, Elijah.
A squared plus B squared equals C squared.
Okay, a squared plus b squared equals c squared. Okay, so I've heard a formula. What's that formula relating to, kids?
So the formula for a triangle. The longest side of the triangle.
To help find the longest side of a triangle. Okay, is it a specific kind of triangle?
No.
No?
No. A right triangle.
A right triangle, exactly. One of the angles has to be how many degrees, kids? 90 degrees. So you guys have had exposure to this, and today we're going to take some things a little bit further with this. So 9.1 is titled Pythagorean Theorem. Central question. How about a volunteer to read this for me? Go ahead.
How can you prove the Pythagorean theorem?
How can you prove the Pythagorean Theorem? Let's do something here real quickly. I'm going to take some paper here. I'm going to cut some paper up. I'm going to cut 4 pieces of paper up. I'm going to have you meet me at, how about that table right over there? Okay. And, this will be kind of fun. I need some, does anybody have like a marker or a pencil or a pen I can borrow real quickly? Okay. So, watch this right here. This will be kind of cool. You ready for this? So this involves what kind of triangles? Hopefully I have 4 pieces here. 1, 2, 3, 4. Perfect. This is going to be cool. Ready to watch this?
Yes.
I'm going to cut this as straight as possible. You ready to watch this?
Yes.
Okay. Which angle is my 90 degree angle? So let's call, which side would be C in this? The long side. So this side would be C right here, wouldn't it? Does it matter what I call A and B?
No.
How about I call the short side A and the other length B? You guys cool with that?
Yeah.
Now how many pieces of paper do I have here? Now what's really interesting about it is this. We said A squared plus B squared equal what? Okay, so I take my little sticky triangles. Like my little sticky triangles? Watch what happens here. I'm going to put this side like so. You guys okay with that? I'm going to put this little side like, oh my gosh, this is like gold. Posted triangles. I could make like posted geometry shapes, not just squares. I could make them all for math classes. They're $1 million idea. This is the other side, C right here, right? Oh, these are parts of the work. That's what this works. So this doesn't work. It'll be pretty simple. You guys agree that this is C right here again? Agree that this is A? Agree that this is B again? Okay. Yeah, that's pretty good. Pretty good. Let's try this again. Now, guys, what do I have on the outside? C. What do you think I'm going to continue to have on the outside?
C.
Why am I getting 90 degree angles down here when I put my triangles together like this?
Right triangle.
Because they're right triangles, yep. Think about it this way. Pretend this angle is 90 degrees. What if this was 30 degrees down here? What would this have to be? Be really careful. If this was 30 down here, what would this be up here?
7.
Close.
60.
60. But isn't this triangle the same as this right here? So this angle and this angle are the same. 30 to 60 makes this what kind of an angle here? Well, here's what I've formed here, kids. Why is A squared? You guys have heard this formula a million times. A squared plus B squared is equal to what? Why is that true? Anybody know why that's true? Anybody?
Because 30 plus 60 is 90?
Yeah. Well, it's true. If that was only as easy as that, that'd be cool.
Because doesn't the triangle have to add 20?
Let's talk about this. Whose pen is this, by the way? C squared right here is going to equal C times C, right? It's going to be the area of the 4 yellow triangles plus the area of this hollow shape right here. Isn't that the area of C squared? Agree with that? Okay, what's this distance right here? What's this distance right here? So what this distance right here be? This whole distance B minus A. That's rubber over. Isn't that B minus A? Help me find the area of one of these triangles right here. What's the base on it? And the height. Base base and height of any triangle, how many degrees apart are they? 90 degrees. So in this right here, any base and any height is going to be A times B times half. So my triangle shapes, listen to this. My triangle shapes are equal to 1/2 times A times B. But how many triangles do I have, kids? What's half of 4? So the area in yellow, all 4 of these triangles, remember, let's put this in your head, it's equal to 2AB. You got 2AB in your head? Okay, that's the 4 triangles, but I have to add in the area of what? Well, you said this was B minus A, and this is B minus A right here. You guys remember how to FOIL stuff? Yeah, okay, here we go. B times B, what is it? B squared. B. What's minus AB times minus AB? Negative 2AB. Good. What's negative A times negative A? Watch what I have right here. Everybody get close. Okay? I'm going to write upside down, because that's going to allow you more to look at all the terms. But the 4 triangles here, is equal to what?
280.
2AB. We're going to take 2AB. And we're going to add in what B minus A to the second power. So this here plus B squared minus 2AB plus A squared.
There he is, really, see if I can fit
What's
that.
2AB?
I didn't realize it.
Oh, it's nothing.
It cancels out. All of a sudden, kids, what's about B squared is A squared is equal to this whole thing to what? C squared. It works, doesn't it? So in any right triangle, you guys know that A squared plus B squared is equal to what? C squared. That's how it comes about. That's pretty cool, isn't it? I think it's pretty cool. I'm just going to leave that right there for the next class. Then you look underneath it. Parson, what the hell is this? You figured it out. I figured it out when I was your age. You figured it out. Right, guys? Let's roll. Let's see if we can learn some things about this today. All right, so you know this. I just wanted to give, and again, I'll never expect you to remember that right there, but it's true. It does work, okay? So, goals to answer this question, how can you prove the Pythagorean Theorem? What's the first goal we're looking to accomplish today? And I think we'll do okay with that. Guys, what's the converse of something? If I say if red, then blue. If I say if red, then blue, what's the converse?
Then blue and red.
If blue, then red. Switch the hypothesis and the conclusion around. And then we're going to do some classifying of triangles using some certain theorems related to the Pythagorean theorem. So here's how this stuff works. First, we need to have a good vocabulary. So the first vocab, Pythagorean triples. Ooh, this is an interesting one. You guys know the most famous Pythagorean triple? In other words, 3 lengths from a right triangle that you would know. Probably the most common one is, I'm going to draw up here. Your probably most common Pythagorean triple is going to be, well, first of all, what is a Pythagorean triple, kids?
Instead of 3 positive integers.
Yeah. Has to be integers that satisfy this. So as an example, here it is. Here's my triangle. Not a very good one. Gosh dang. It's made by the Ford company. Junk. There we go. Probably the most famous one. First of all, what kind of a triangle must I have?
Right triangle.
This 3 and 4. What's 3 squared, kids? What's 4 squared? If I add 9 to 16, kids, where are you at? So that last side in the hypotenuse, you would say, Parson, that's root 25, but root 25 is a perfect square. What are you going to have up here? So when I get 3 nice numbers like this, 3 integers, in this case 3, 4, 5, we say, hey, that triangle is indicative of a Pythagorean triple because they're whole numbers when you end up with them, okay? It's not 5.72. It's not found by taking the square root of 68 or something like that. Okay? It's just a whole number with 0.0 as your decimal, okay? And there's more of them, and we'll talk about it. I have a table of them in the notes, okay? You guys know what a right triangle is. I don't think I need to draw that, do I? Okay, what are the legs of the right triangle? In the example above, which 2 sides would be the legs? 3 and 4. The two legs form which angle?
90.
Yeah, I think of it this way all the time. Legs, what letter does that start with?
L.
L. Okay, I'm not calling you guys a loser, right? Makes sense? I just think of it this way. If you can find the L shape, those are the two sides that are the legs. They make the right angle. Right angle is like the letter L, isn't it?
Yeah.
Okay, so the legs in this example, above, my legs are what values?
94.
My legs are 3 and 4. Okay? Hypotenuse is a side opposite the right triangle, or the right angle on a right triangle, or always which side? The longest. It's always the longest. And in this example up here, what is the hypotenuse? The hypotenuse is 5. Okay? So definitions, I think you should be pretty okay with this. I think that this is stuff that you've been exposed to in the past. I just want to quick review that so that we're successful with what we're looking at today. Guys, in the notes when you see core concept, these are things that are pretty important. I always tell kids, if you see where it says core concept, I think you should highlight them. Okay, I think these are pretty important right here. Okay, important stuff. I like to put a little drawing with this. Okay, you know the Pythagorean Theorem. It says in a right triangle, the square of the length of the hypotenuse is equal to the sum of the legs, sum of the squares of the leg lengths. And it's like this. I'm going to draw another triangle in here, kids. Here's my triangle. Okay. Guys, which side do they usually use for hypotenuse in that formula? A squared plus b squared is equal to c squared. Which two sides represent the leg in the formula? A and B. So this might be A. This might be B. But the longest side is always going to be what? Okay, the two legs are interchangeable. I don't care where A goes, I don't care where B goes, but the longest side has to be which variable every single time?
C.
Exactly. Okay? So this is what this is simply saying. And they kind of give you a weird order when you see it in your assignment today. They call it c squared is equal to a squared plus b squared. But isn't that the same thing that we've been programmed to know already? Okay, so questions on the first page, though. All right, you guys are going to help me a lot on the second page. I have a nice little table up here for Pythagorean triples. Okay, common Pythagorean triples right here. The first one we talked about in the vocab up there about Pythagorean triples and what they are was which one? 3, 4, and 5. You know, this chart gets to be kind of handy because these work out. Common, triples. 3, 4, and 5. How is 3, 4, 5 related to the next one down here, 6, 8, and 10? All the values are double. What about the 9, 12, 15? If you ever have sides in a triangle go to a ratio of 3 to 4 to 5, meaning like whatever 3 times 12 was, 4 times 12 was, 5 times 12 was, those would be Pythagorean triples. Okay? Another example is what, kids? Let's see how good we are. What's 5 squared? What's 12 squared? What's 25 and 144 add up to? What's 25 and 144 add up to? Turns out that the square root of 169 is actually 13. So I'm not going to go through all these, but here's some common Pythagorean triples. So guys, I have two triangles. I have a right triangle. Legs are 14 and 48. What's the hypotenuse? Look at your chart. Legs are 14 and 48. What's the hypotenuse? 50. Okay. Suppose up there I have a triangle where the hypotenuse is 51 and a leg is 45.
24.
What's the other leg?
24.
Okay. So the first two values listed in all those triples are they legs or hypotenuse? And then the last one is my... Okay, so there's just a chart there. Okay, let's talk example 1. You guys are going to help me and tell me what to do. Show of hands on this using Pythagorean Theorem. You should be able to nail this right here. It says find the value of x, then tell whether the side lengths form a what? Okay. Tell me what to do here, kids. We're trying to find an unknown. What do I have to do? Okay, so what are you going to plug in for a and b, kids? 4 and 5. So you want to start this out as... Whoops, that's not a very good choice for color. Okay. You want to start out how again? I heard 4 squared first.
4 squared plus 5 squared equals
Just x?
X squared.
X squared. How many agree with the way that this is set up? 4 and 5 are in for my legs.
Yep.
X is in for the hypotenuse. Okay, so we've got some mental math to do. If you're not sure about stuff, calculator always comes in handy. Calculator comes in handy. Okay, never mind. What's 4 squared? 16. How about 5 squared? Ugh. All right, how about my sum of 16 and 25? 41. Daniel Suarez. Guy likes to fight. Hey. Square root of 41, kids.
6 point something missing.
Yeah, so they're probably going to they're going to call us the square root of 41. By the way, is 41 a perfect square, kids? No. Okay, so you might leave your answer as square root of 41. I'm not sure. I haven't looked ahead in this assignment before to know. They might ask you to leave it as square root of 41, or let's go maybe 2 places if you punch that in. What do you guys get when you punch in square root of 41? 6.42? I'm sorry, I actually didn't hear you.
6.40.
40. Okay, so about 6.4. So we know how to use the theorem. The question becomes, with that information, is that a Pythagorean triple, kids?
No.
Why not?
It's not on the chart.
Not on the chart. That's number 1. But number 2, this is not a whole number, is it? It's not an integer. Okay, so last part is this. Does this form a Pythagorean triple? This is not, boy, my pen's not working very good. A Pythagorean, come on. This is not a Pythagorean triple, kids. Whoops, come on. Okay. So what I'd like you guys to do is try example 2 on your own. Make sure you're good with it. When you get done with example 2, check with a neighbor. Make sure you agree. Be careful about what you're putting in where in terms of the formula for this. You guys only have advice today, right? All right, what are you guys coming up with here?
Do you want us to round like 10 to 100?
You know, I like 2 places normally, and when you get into your big ideas assignments, it's going to typically tell you how to round that. Guys, I look at this right here, and maybe I do the work for this, but I think one thing I might have done is say, is 15 a leg or hypotenuse, kids? It's a leg. How about your 25, kids? I might have just jumped up to the chart and said, ooh! Is there anywhere up in this chart where 25 shows up as a hypotenuse, maybe?
Yeah.
Where?
7, 24, 25.
Okay, but does 15 show up as a leg?
No.
Ah, darn it. Is there anywhere else where 25 shows up as the hypotenuse?
It would show up with 3, 4, 5.
Would it?
Times 5.
Oh, so you're saying if you multiply all these by 5 right here, this one that would have worked would have been 15, then what? What's 4 times 5?
20.
And then what's... Ooh, if I use this idea of 3x, 4x, 5x, maybe... Is the leg 15?
Yeah.
Now, if you didn't catch that through the chart, or you didn't make the connection with the ratios of sides for triples, that's okay, because I'm going to guess a lot of you probably went through and did the work. So you guys tell me what your work is to do this.
25 squared minus 15 squared.
Okay, and some of you are already ahead of me. I'm going to write it out as 15 squared first. plus x squared equals 25 squared. I'm hearing some people say, let's take 15 squared away from 25 squared, right? Okay. Leighton, did you have a question?
I just did it 20.
Oh, that's fine. And I think you probably used the ratio, didn't you?
I did 25 squared minus 15 squared.
Yep. And that's exactly where we're at right here now, right? You just saved yourself a step, didn't you? Okay, what's 25 squared minus 15 squared become, kids? 400. So x squared is 400. Gosh, kids, when you root 400, what do you get for a value? Is 20 an integer? So up in my diagram, kids, are all three values integers? So it's 15, and watch this, it's 15, 20, 25, a Pythagorean triple? Can I put PT up here for Pythagorean, or P triple, is that okay, kids? I don't have room to write it. By the way, kids, if you took 5 out of all these right here, what's 15 divide 5? What's 20 divide 5? What's 25 divide 5? You see that 3, 4, 5 relationship right there then again?
Yeah.
Okay. First couple pages, show of hands. How many are on board with me right now? Feeling pretty good about it?
Yeah.
Okay. All right. Nice hairdo, Seamus. Okay. All right. Any questions so far for me? All right. Help me out here, kids. Third page. Ooh. The flagpole. What's that?
This is hard.
The flagpole shown is supported by what, kids?
Pole.
A pole and what else here?
2 wires.
Yeah, 2 wires right here to support that. It says use the
Pythagorean Theorem.
to...
Approximate the length of each wire.
Well, what's going to be true about these 2 triangles right here, kids?
They're both.
They're going to be the same, aren't they? Here and here. You guys should easily be able to get this. Approximate it. Let's go nearest tenth on this, because everything's measured in tenths here. So how are you going to start this to figure out the support wire? Is X a hypotenuse or a leg, kids? Okay, you know this. Well, how would you set this up? 15.1 squared.
8.5
Okay, or in our case, yeah, X represents the... Okay, gosh, I don't know those off the top of my head, so if somebody would run 15.1 squared plus 8.5 squared for me, that'd be great. Sonny, are you my puncher today?
300.26.
300.26. I have a question before I even finish here. The 2 lengths that were given, 8.5 and 15.1, my answer related to the 2 sides better be fill in the blank. Am I looking for a leg or hypotenuse right now, guys?
It better be bigger.
So it better be bigger than what?
The legs.
Okay, so my answer, it better exceed, what's the biggest value up there?
15.
15 point. Okay, what is the square root of 300.26, kids? 17.3-ish?
Yeah.
And since this was a word problem with a diagram, we probably better label it as 17.3. I'm sorry, 17.3 feet. I agree, 17.3 feet. You guys know this stuff, okay? Let's get into some things that are a little more difficult. Some things that we can do with Pythagorean Theorem that you maybe didn't know already, okay? How many had 17.3 feet? I'm curious. Okay, questions to this point at all? Easy peasy, Harkness? Sweet. Rock and roll, let's move. Hey, another one here, kids. Okay, another core concept. This is an interesting one, okay? Kids struggle with this, whether you believe it or not. Everybody hears Pythagorean Theorem like, ooh, this is pretty easy. Okay? And then we get to stuff like this, and all of a sudden, it's almost like you took a left turn when you should have taken a right. Or you took a left turn from the right turn lane. Bad things start happening. You don't want to do that. Okay? So it says the converse of the Pythagorean Theorem. The square of the length, if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is what type of triangle? In other words, it's just restating the formula. It says if c squared plus equals a squared plus b squared, then the triangle must be what kind of a triangle?
Right.
So let me do this right here. I'm going to put a triangle up here. Okay, the question becomes, if I have a triangle where 4, 5, and 6 are my lengths, where 4 is a length, 5 is a length, and 6 is a length. Okay, I want to know if that's a right triangle. Okay, well, if it's a right triangle, that would mean that the sum of these two sides squared would have to equal 6 squared, right? So what this would imply is that, well, 4 squared plus 5 squared would have to equal what? Okay, what is 4 squared, minions? What's 5 squared?
25.
And what's 6 squared?
21.
What?
Well, you go get 36.
36.
21.
No.
All right, what is 16 plus 25?
41? I don't know.
41 is equal to 36, and those two values turn out equal. Did a squared plus b squared equal c squared here? So by converse of the Pythagorean theorem, I can say since 41 does not equal 36, 41 does not equal 36, this is not a right triangle. So let's do one together down here. Okay, I'm going to show you how to handle these roots that are in here. I have a triangle. Sides are 8, 12, and 4 root 5. Okay. I have an idea. I don't know what 4 root 5 is. 4 root 5 might be more than what? I would check to see what 4 root 5 equals first in your calculator. So somebody do 4 times the square root of 5. 8 point something? So what's the longest side up here in that triangle already? So 12 is, right? So let's talk. Is this a right triangle or not?
No.
Let's see. I would have to go 8 squared plus what? See if that equals. Okay. Help me, kids. I know the 8 squared. That's easy. Isn't that 64? I know a 12 squared. That's pretty easy. What's that? I'm struggling with the 4 root 5 squared. Okay. You want the easy part? You want an easy way of doing this or the difficult? Let me just see. What's 4 root 5 squared? Does anybody know?
8.9.
Okay, here's how you do this. This is the same as 4. This is the same. I'm going to toss over here. This is the same as 4 root 5 times 4 root 5, isn't it? When I square that, you guys agree? You ready for this? What's 4 times 4?
16.
What's root 5 times root 5?
5.
It is 5 because it becomes the square root of what? So 16, this is really 16 times 5, which is 80. So 4 root 5 squared is what value? 80. So in my notes, kids, in my notes, we need to call this, oh, where did I set my pen at? Yep. Oh, it's in my hand. Guys, does 64 plus 80 make 144?
Yeah.
This is true, isn't it? This is true. So I'm going to say, you know what? This is true right here. So is this a right triangle?
Yeah.
A is a right triangle. Okay. You guys do part B on your own. Determine if the length's 9, 2 root 30. You might want to take 2 root 30 and see how what? See how big that is. We need to know which sides go in for A, B, and C. How are you setting this one up, kids? Is 14 indeed the longest side? Yeah, because isn't the square root of 30 going to be somewhere between 5 and 6? And 2 times 5 is 10, 2 times 6 is 12, so that's going to be shorter, so we're going 9 squared. All right, help me, minions. Plus 2 times root 30 squared equals... All right, what's 9 squared? 81. You guys want the trick on this one right here? Let me do this for you. Over here, root 5 times root 5 became what value in the end? Became 16 times 5, right? So root 30 times root 30 is just going to be 30, isn't it? What's 2 squared, though? What's 2 times 2?
4.
This is really going to become 4 times 30, which is what? 120? What's 14 squared? Kids on the left. 81 plus 120. What have you got? 200 and? So the question becomes, first of all, statement true or false with the values I put in? False. So if I had to write this and I don't have room, you might want to write this. If that's false, can that triangle be a right triangle? No. So the converse of the Pythagorean theorem is basically saying, I'm going to give you the sides, you tell me if it's a right triangle. The normal Pythagorean theorem says, here's a right triangle, find the sides. We're doing the opposite. They're saying, here are the sides, is this a right triangle? Steps and process still the same, kids? They're just asking you different things about the same pieces of information given there. Okay? Are you with me?
Yeah.
Why is part A a right triangle again? Okay, because what equaled each other, Grace?
A squared plus B squared equals C squared.
Okay. Why was this not a right triangle?
A squared plus B squared is not equal to C.
I love it. That's all you need to know about the converse of the Pythagorean theorem. Okay, very good. Very good. All right, you ready for last page, kiddos? Last page. Let's rock. Okay, another core concept, and this is not about the Pythagorean theorem as it relates to being equal to other values. This all of a sudden is called the what?
Pythagorean inequality theorem.
Of course. We can't leave less than and equal or greater than signs out, can we?
Of course not.
No, that would be not good. Okay? Couple things going on here, kids. It says for any triangle ABC. We just talked about, is a triangle right or is it not right? So when we found in part B that that's not a right triangle, we say, okay, if it's not a right triangle, what kind of triangle is it? So over here, kids, it says for any triangle ABC where C is the length of the longest side, the following is true. It says if C squared is what here, kids? Let me give you an example. How about we pick values where A is equal to, let's go 6, B is equal to, 10, and let's go C is equal to 11. How's that sound? Okay, here's the deal. What's 6 squared equal? So I'm just going to go ahead and put a 36 over here. What would B squared equal? What's C squared equal? 11 squared is what? Guys, when I take the 36 and the 100 and add them up, so I'm going to say 121. Is 121 greater than the 136 or less than the 136? If C is less than the two sides, if C is less than the two sides added together, in other words, 121 less than 136, or was C squared less than A squared plus B squared here? My hypotenuse square is shorter than the sum of the squares of the legs, right? What kind of triangle is it? First of all, maybe I should back up. Is this a right triangle?
No.
These don't equal. So since 121 is smaller than 136, it must be what? Okay. Do I need to go over an example that says it's obtuse?
Nah.
Okay, the opposite is true. If this number was not smaller than A squared plus B squared, but... Okay, so you guys try the last one on your own. You tell me if this triangle down below is acute, right, or obtuse. Your lengths are 14, 15, and 11. You tell me what kind of triangle that's going to be given those three lengths. When you get any answer, check with someone. What are you guys finding out?
Cute.
I'm hearing acute.
Yeah.
Anybody for right?
No.
Anybody for obtuse?
What at first? And I did it wrong. So
Okay, so I'm a little confused here. I need someone to walk me through this. How'd you come up with acute?
I just guessed because.
I just guessed. I don't know if I want that.
Well,
though.
I mean, I looked at the 14 and 15. I was like, well, that's not a writing.
Okay.
I don't know how. I just knew it wasn't.
All right, Leighton, what do you think, buddy?
Well, the squares are 196, 225, and 1.
Okay, so let me write these down. My sides were 11. What'd you say? 11, 14, and 15 were my sides. All right, roll with your squares again.
196,
Which one does that come with?
14.
So the 14 becomes 196 after being squared.
15 is 225. And 11 is 221.
How many?
221.
Isn't it 121?
Sorry.
Okay. So when I square all these, when I do all this, we end up with 121. Well, first of all, are they even equal? Okay, what do you get when you take 121 and 196 together? 317. 317 to 225, how does that compare? So is the C side bigger than the A plus B or smaller? Since this is true right here, so by this, C squared is less than A squared plus what? So it must be a cute triangle like me. No, don't use that joke anymore. Not bad.
I would recommend.
Few looks out there like, oh my god, I can't believe we just said that. Okay. How you guys feel about this? What questions